All right, let's look at the practice exam 3, problem number 6, part B. All right, so I'm going to actually explain this hint here. All right, so integral 1 over x squared plus a squared with respect to x is 1 over a, arctangent of x over a plus c. All right, this can be found by using substitution. So let's do a substitution. All right. So first, I'm gonna just divide top and bottom by a squared, right? So I'm gonna just so divide top and bottom by a squared, right? So this guy by 1 over a squared, right? Then what happens is you're gonna get this integral. Right, so a squared divided by a squared would be, x squared. So x over a squared on the bottom. A divided by a is just going to be 1, right? Then on top, you're just going to have 1 over a squared with respect to x, right? So it's the same integral, right? So then I'm going to use a substitution. Let's say let u be x over a, right? Then if you take the derivative, du over dx, you will get 1 over a, right? Then take the reciprocal of both sides. You get dx over du is equal to a, right? Then we can just multiply through by du. Then you get the dx is equal to a du. All right, so we can rewrite this integral as, right? So you have an integral, right? 1 over a squared is just 1 over a squared, so I'll just put that in. And then this is a u squared plus 1. And dx is actually a times du. Alright? Then you can have, so a, then you have an a squared on the bottom, so you can cancel one of the a's, right? Then you get this. You will get 1 over a is a constant, so I'm going to put it right in front. Then you have an integral of 1 over u squared plus 1 du, right? That's actually arctangent, right? So it's a 1 over a arctangent of u plus some constant c. Right, then putting the original expression back in instead of u, so you have 1 over a arctangent of u is x over a plus some constant c, right? So that's how they came up with this formula right here, right? So but for this problem you can just use this hint, right? But anyway, so we have to make this guy look like this hint, right? So coefficient of x squared has to be 1, and now we have 4 there, right? So what we're going to do is we're going to divide top and bottom by 4, so multiply by 1 over 4, right? So bottom by 1 over 4, right? Then what you get is integral. Right, so you have a 3 over 4 on top, right? Then you have x squared, so you have x squared because 4's cancel out, and plus, right? You have 9 over 4, so we can write it as say 9 over 4, right? Then you have a dx, right? And I'm going to clean up a little bit further. So 3/4 is just a constant. I'll just put it outside. 3/4, right? Then you have an integral, right? Then you have, so it's going to be, since 3/4 is in front, so 1 on top. you have x squared plus, right, 9 over 4 is same thing as 3 over 2 squared, right, dx. Now we can use this formula here, right? So 1 over x squared plus a squared. So you can see that this is our a, right? So 3 halves is a in this formula. So let's just follow that. So you have, right, 3/4 is just a constant, so it's still there, right? Then you have a 1 over a, or a reciprocal of a. So a is 3 halves. So reciprocal would be 2/3. Right? Then you have an arctangent. So you have an arctangent. Then you have 1 over a. So it's going to be x over a. So it's going to be 2x over 3. Right, then you have plus some constant c, right? Then after that, you just have to clean up a little bit. So you see that here, 3 on top and 3 on the bottom cancel out, and 2 on top and the 4, so it is going to be 2 on the bottom, right? So therefore, you will get 1 over 2 arctangent of 2x over 3, and then plus some constant c, right? So that's how you get the result, right? So you don't have to do this part. Once a hint is given, you can just go straight to the hint and use the hint to find the antiderivative, right? That's it. I hope that this was clear.